Hello, welcome to Code Decipher. Today we are going to decipher C# generics. Generics is something that gives us type independence and type safety. So imagine if you have a big storage container where you can keep different items. The cool thing about this storage is that you can decide what kind of items it will hold. You might store fruits, numbers, or even objects. Now here's the magic of generics. It allows us to define this container in such a way that it can hold any type of item. This is called independence, but only one specific type at a time. This is called type safety. We can also call methods inside the storage to add, remove, or replace these items. Now let's go to the coding environment. We have created a class called storage. Since we are not sure what the user will be storing, we have used generics. To use generics, we write t inside the smaller than and greater than sign. T is a type parameter which acts as a placeholder for now, and when the user decides what data type to use, then it will hold that type. It does not have to be T and can be everything. It's just a convention that Microsoft decided to use, so we just write T. Now we have created a stored items list which will store the items that the user has passed in. Think of these as the cells of the container. If we make stored items list public instead of private, any code outside the class could directly add, remove, or modify items in the list, bypassing the methods add, update, or remove within the storage class. We do not want this, so stored items list has been set to private. List is a keyword to create list. Note at this point we do not know what type will be passed in, so we are still using type T. Stored items is the name of the list, and this section is instantiating the list, as all list needs to be instantiated before use. Note we are again passing in type T. This ensures type safety. Now we have created a method called add, which will add item to the stored items list. Public means this method can be accessed outside of storage class. Void means this method do not return anything. Add is the name of the method. We are passing in type T, and item is the name of our parameter variable. This ensures type safety. For example, we cannot create storage of int type and add string type to our stored list. Now we will add the item to the list. Stored items is the list. .add is the built-in method to add to list, and we are passing in the item value of type T. Now let's create another method which will get the item from the stored item list by its index. We want this method to be accessed outside of storage class, so it's set as public. This method needs to return the item at specified stored items index, so we need to set it as type T, same as stored items. We know that our index is a number, so we write int and call our parameter name as id. So this is the index, and getById is our method name. Return simply returns the item at the supplied index. This is the list name, and that's the index. So return simply returns the value at the index. Now let's go to the main method and create an object from storage class. This is the class name, and we are passing in type string. This is the object name. This section creates a new instance of the class object. Note we are also passing in string over here. The string parameter creates type safety. Once we have declared the type string, we cannot use another type when using this object. We can now call our add method using the dot notation followed by the method name and pass in string apple. Using the same method, we can add mango and banana. We will also call the getById method and print it to the console. Let me copy the same line of code twice. Note that the index starts at 0, so I will call 0, 1, and 2. Now if we press start, it should show us apple, mango, and banana. The output is exactly as expected, so the methods add and getById are working properly. Let's create few more methods. Let's go to our storage class. I will hide this method to create a bit more space. Now let's create another method which updates the current stored items with new item at a given index. Public means we can access this method outside of the storage class. Void means function is returning nothing. Update is the name of this method, and we are passing in int type, and the parameter name is new item, and this is of type T. So this will be our new item. So this will be our index. Now we need to assign the value at this index as our new item. So this is our list, this is our index, and we are assigning new item value to it. Now let's create another method which removes the item from the given index. We have named this method as remove. We have also passed in int type and named our parameter as id. So this will be our index. Now all we have to do is call our list. Dot remove at is a built-in function that removes the item at specified index, and we have passed in our index, which is id. So this should remove the item at specified index. Now let's create our final method which displays all the items. This method is public because we need to access it from outside this class. We also need to display everything, so we are returning the entire list which is of type T. Get all is our method name. We are returning the copy of the stored item list. We do not want to return the original stored item list because it exposes our internal data structure. It's better to return a copy of the list to prevent unintended changes. Now that we have created multiple methods, let's go to our main method and call this newly created methods. First, we will call in our update method, and we will pass in index1, and our new item will be pear. So instead of mango, it should display pear. Now we'll print the item at index1 and see if we get pear. As expected, we are getting our results as a pear. So this mango used to be, and this is the new value. So the update method is working correctly. Now I will remove the item at index 1, so this pear must be deleted and banana must take its place. Let's print the item at index 1 and see. Yes, we are getting the correct results. So the pear has been deleted and banana has been displayed. So this remove method is working correctly. Now I will create a variable called allItems, and I will call the getAll method. And we will print all items to the console using a built-in .join method, which is a string method. So what this does is adds the space, comma, space in between individual items of the list and prints it to the console. So the string is the data type, .join is a built-in method. This is the separator which will be added in between individual items. Let's hit start. Yeah, now we have apple and banana. When we create a generic class, we can limit what types can be used with it. This is where constraints come in handy. Constraints help us to enforce specific rules on the type T. To use constraint, we need to use the where keyword followed by colon sign and the constraint. In this example, we have used class constraint. Using class constraint ensures T can only be a reference type like string or a custom class. We cannot pass value types like int, bool or datetime because those are value types and not reference types. Let me demonstrate this. I will delete all of these and add in a int data type, an int. I can see squiggly lines below these, and this is saying the type int must be a reference type. So that's why we know that our constraint is working, because this T semicolon class is enforcing that our T type must be a reference type. Let me undo this so we can go back to where we were. So now we don't have any errors. So this is how we use generics. So why use Csharp generics? It provides us type independence. We can write a class method or interface that works with any data type. For example, list of T works with list of string or list of int. When to use Csharp generics? When we are working with collections of different types, then we should be using Csharp generics. Why use Csharp generics? Generics ensure that the correct type is used at compile time. This is the time when the compiler converts the code into a machine readable code. This prevents runtime errors caused by invalid casting. When to use C# generics: when we want to enforce type safety while allowing flexibility, i.e., for example, we previously used a storage class that can handle multiple data types but ensures consistent use of a single type. Why use C# generics? It offers code reusability. We don't need to write multiple versions of the same class or methods for different data types. Here's an example. Without generics, we need to create different classes. With generics, we can achieve the same results with just one class. When to use C# generics: whenever we want to avoid code duplication. Instead of writing separate implementations for different types, we can just use a generic solution. Finally, here's a quick coding challenge. Create a custom generic stack class called custom stack. This custom stack should take in type T. Think of this generic stack as a list. Your class should provide the following functionality. All of them are listed over here. For example, when we do stack.push, should add an item to the top of the stack. So when we run this line of code, should put apple. When we run this line of code, should put banana at the top. And when we do run this, should put cherry at the top. Now if we run the pick method, then it should only return the top item without removing it. So it should return cherry but should not remove it. But if we run stack.pop again, then should return cherry and remove cherry from the top. Now if we run pop again, it should return banana and it should remove banana as well. Now when we run isEmpty method, then it should return false because we still have got apple over here. When we run this pop method again, then it should return apple and delete apple. And now when we run this isEmpty function, then it should return true. So hopefully this makes sense. Let me know how you get on with the coding challenge. Thanks for watching. Please feel free to like, subscribe and comment. Happy coding.